first introduce you, Afşin. Afşin is a friend of mine for like 32 years now. So we were friends. We are friends from high school, Ankara Fen Lisesi. And then he went to Istanbul Technical University and he got his industrial engineering degree from İTÜ and did his graduate studies at Portland State University, receiving 2 MS degrees in system science and engineering management. After then, he has been living in the United States and currently working for Meta and leading data science and application research teams. Before joining Meta in 2019, he worked at Groupon, eBay, IBM, Bank of America, Merrill Lynch, Siemens corporate research on various business domains, supporting data science and machine learning teams. He loves being part of taking a vague problem, developing a data-driven solution to solve it, and landing business impact. So he has lovely old twin boys, and who are 2 super fun troublemakers. So we arranged this like meeting before they wake up. And he likes everything that involves outdoors and tries to get the most out of Great California outdoors. So the screen is yours. Again, thank you very much for accepting our invitation. And we are here to like hear what you're going to talk about. Thank you very much.
Awesome. Yeah. Thanks much, Çiğdem, for the introduction. Really appreciate the invite from Koç University. Happy New Year to everyone too. Let's get to it. I did review some of the previous talks given in this platform. They were really some great talks. This is a bit different though. This is a bit more from a applied practitioner point of view. To run an ML project end to end, almost like MLDC, like the ML development lifecycle end to end. What kind of problems we could face in company. So I did have a chance to lead probably hundreds of data science ML projects. Some of them failed, some of them didn't. And I did learn, I believe, quite a bit lessons learned throughout that. I want to share those with you. So the tone in the presentation might sound a bit like too prescriptive. Please take them as if like I am talking to myself, like, hey, I've seen these are the lessons learned. And some of them are subjective opinions too. In fact, one could argue in both ways. So it's completely fine if you guys...
We have a problem to see your screen. So it always says loading in a black screen.
Shall I, let me just maybe... Or resume share. Your screen share is paused. Who paused it? I didn't pause anything.
Neslihan Hanım.
Resume share. Let me stop and...
I didn't pause it.
Okay, sure.
Share screen again. Why is not...
Okay, now everything is good.
I cannot do slideshow for some reason. Interesting. Okay, now it came maybe to the internet. It's maybe there's some lag. Is it? I see loading, but not loading yet. It's interesting that the video conference is working, but not sharing the...
We saw your slides, but not in the like full screen.
What about now? I'm seeing now. Did it load for you guys?
We don't see anything right now. But we saw the slides without the slideshow.
Okay, try one more time. This time maybe I'm not gonna do the force to full screen. Maybe that might work. If it doesn't work, another option could be maybe
We
one of you
can
could advance
see your
to.
slides without the full screen option, if you like.
But now you cannot see them yet, right?
No, it says click
Yeah.
to exit full screen.
But now you can see it, because now I can see
Now
it.
we can see it.
And then
We
it
can see
changes
the
now.
contents. Yeah.
It changes now like this.
Yes, that's correct.
Okay, perfect. Okay, let's get
Okay.
to it then.
Okay.
Sorry for the hiccup. So yeah, what I was saying, some of these opinions might be a bit maybe controversial, which is completely fine, subjective. If you guys think differently, I'd love to hear those. Like, you know, we do this kind of conversations all the time. Okay, with that, let's get to it. So I say this all the time. Like, developing the right model in ML world, it is actually much harder than developing the model right. Like, very often, unless you don't know what you're doing, you don't do a big mistake with the typical model development steps, and you build the model right. But unless you're very quite experienced, more often than that, actually you end up building the wrong model. This is like surprisingly common in the data science world. Typical that your program partners, product partners, business partners could come and ask you a bit too prescriptive request, build me a churn model. And if you just jump on and build them a churn model, very often that's not the right model you were supposed to build. Maybe it was supposed to be incrementality model, like a net lift, uplift modeling. So it is super important that like the research question is formulated well. Like, I cannot emphasize this enough. In fact, most of the senior people, like either the managers or the senior scientists, this is the part, okay, we have power now. This is the part that they add the most value generally. And as a continuation of this, BRD, business requirements document, generally, right, the technical people, they don't like BRDs all that much, because generally, you know, they are written by the program people. There's like given the requirements to the developers, to ML scientists. But actually, no, BRD is not your for. You got to embrace the BRD. You got to be part of the process. That is the part that you have a chance to take the problem, convert to the research question, clarify the definition of done, scope, super important. Like, when are they gonna know we are done? Clarify the definition of success metrics for the project milestones, dependencies, implementation details, super important. So taking the time, working with the stakeholders, and then clarifying this, super important. In fact, like almost any company I worked, one of the first things that I always establish is checkpoints in the ML projects. You can establish multiple, but you should need at least two. One of them is a research proposal. So that means before people write the first line of code, there needs to be a proposal which has all those components I mentioned. And then, because if you go in tangent that direction, then you will go separate ways. Super important to align in the very beginning. And the second must-have control point is the production deployment. Before you deploy production, you do typical all the back testing, forward testing, all of those, and then you get a sign off, and then you deploy the production. And then when you're thinking about this in the BRD phase, in the initial development phase, always thinking about the very end from the very beginning is super important. I cannot emphasize this enough. It forces you to think about, okay, I'll build this, how is this going to be used? So important question, like, why am I building this? You always say asking 5 whys to your stakeholders, most important to yourself and to your peers in the peer reviews. And then layers, so what? Okay, you're doing this, so what? Okay, doing it, so what? Now, what's going to be the impact? How is it going to be used? What are going to be the constraints? Super important. And then it really, especially in the corporate setting, ML models, ML solutions, it takes a village. and you need to have one. And in many cases, unfortunately, it's not like there is a perfect project team with all the players in it. You come up with an idea, or you're giving with abstract problems. You will need to convince people and then bring them to the projects. In a typical ML project that supports a product, which nowadays most ML solutions are in a product, so they are done by the product teams, includes SWEs, software engineers, MLEs, machine learning engineers, data scientists, user researchers, because most of the hypotheses, they start with those, data engineers, product managers. There are more roles too. So you need to make sure that you work with them together. So before you really put so much effort on the project, you need to make sure there is this support, the work group around it too. Within this group, the handoffs and the roles should be super clear too. Like, okay, I will build this, then you're going to build this. Defining those dependencies earlier in the process is super important. And most importantly, finding a sponsor is always very important too, because very often there is a BAU, what we say, business as usual, a heuristic, a manual program is going to exist, that your model is going to compete to replace that. So this means by definition, you're going to have some pushback or unwillingness from the maybe program business point of view. This means having someone sponsoring that might help you to pass those initial challenges. Then you can show the data, and then data speaks to yourself. I already mentioned this some degree that it's a village. Another thing that's very often sometimes causes projects to fail is that as a ML, let's say, person who's building a solution, some people tend to have this tendency that, okay, like, give me the problem, okay, and then see in a month, I'll solve it for you. That is like the worst thing you could do almost, because it will be so hard to land. Not only you need so much domain expertise that the business have or the other stakeholders have, that you will need to get that input, but also it will be so hard to land. Things can go south because of unexpected issues, dependencies, etc. It will be hard to explain those to your XFN, to your stakeholders, why things are delayed. So the TLDR, long story short, is it will be really important to pull to pull yourself in the problem definition, and then to pull your stakeholders in the solution themselves too. So people should feel like this is a common thing that they are solving together. So important, whatever their job function is. They could be non-technical, but still they should be part of the ML project. So requirement engineering, I had taken a course on this long time back, and it helped me so much. Requirement engineering is such an important skill set, so I recommend everyone to pick up those skills. It really helps you not only to come up with like your own requirements and the business requirements in an organized way, but also provide clear milestones and then build an MVP and then expand it slowly. It gives that framework. I really recommend that. And the cadence is super important too. When there is, let's say, BRD set, milestones are clarified, there's a project team, how are you guys going to work together? So of course, there are different ways. If it is part of a product team already, most likely they are working as Scrum or sometimes Kanban, but there will be some kind of a sprints. So I would suggest, even if you work by yourself or with only few people, still working in sprints really helps. So it just gives the perspective to build incrementally versus like just build in bigger chunks. Also gives a sense of velocity too, which is always good. This is maybe starting the obvious, but starting simple, I cannot emphasize this enough, because I mean, generally ML, I mean, people are like, of course, they are scientists, they want to work on the build cool stuff, complex stuff, but in a corporate setting, No one is paying you because like you're writing something super cool, super complicated, super fancy, or the most advanced algorithm or library. So, and I'll talk about it later too, why this is important. But also even the end solution eventually is going to require something more complex or fancy. Always, we should start simple. So I always say, like, let's first come up with a heuristic, deploy it out there, and then that's going to be your BAU. That your challenger is going to try to beat that, right? So it just makes things much easier. It also gives you, because in the old days, you know, we used to build a model and then just look at your AUC and then compare it to random. But that's not gonna, no one's gonna buy it anymore. So there needs to be some logical process out there that your model should try to beat that. And then there should be a baseline. Then you can just say, okay, this was the baseline. I did this, I increased it this much. This is my ROI. And then, like I mentioned, starting simple, developing an MVP, super important. But deploying, you gotta deploy your MVP. Like this is the part people usually miss that. They develop an MVP, they present it, they do back testing, this and that, and then everything is good, and then they start expanding it. No, like you gotta deploy it first. This gonna give you all kinds of new challenges that you will need to think about, like how to pipeline this, how to test this, forward test this, all of those. Once you iron out all those details, then you can iterate and then improve the model. I mean, this is like in many companies, this is doing much better. Many companies have either internal systems or they are using third parties. But basically, in order to innovate around machine learning, especially if it feeds a product and then faces like used by the end customer, you need an experimentation testing platform. This was a big differentiator before between companies. There's many companies invested on their own, but nowadays I think almost everyone has access to this, so becoming almost a commodity. But it's really important, and it makes a big difference. Like I work on experimentation platforms that everything was super manual, really glitchy, so many use cases weren't addressed. And for example, now I'm working with some that it is like so easier. Anyone can launch an A/B test or different types of tests much easily. So it is often tempting, right? So for an ML developer to just build a black box as soon as I test it and I show that this thing works, who cares, right? So no one likes black boxes. I'll tell you that. So people will want to understand your model if you're working with other people in the company. And black box, no one likes. It's kind of obvious, but you shouldn't like either. I think it is my main point here, because it's just risk. There are so many peculiarities that could go there, and then you might just it creates hidden layers, complexity. So as much as possible, you should open it up. Sometimes, though, of course, the algorithm you use might be hard to interpret. It happens all the time. For example, in those cases, what we generally do is you build something comparable and easily explainable, let's say three-way, something like that, and then you use that to more interpretation layer, and then you communicate that one for the understanding point of view, and then you use the more hard to interpret one for production too. But of course, this is not the ideal solution too, because then you will need to maintain two models. Another important point is, like, each modeling project is actually a huge understand opportunity. So what I mean by that is, so in the beginning of the model, all that EDA, like the data exploration that you do, but that insight is super useful to your stakeholders. It is super useful to you too. So like sometimes people take shortcuts and try to skip that and then just, okay, let me build a model as soon as possible. But time is super useful. Not only it makes your feature engineering much more powerful, because the better you understand the data, the stronger your feature engineering is going to be. But also those insights, those simple insights, might be a game changer for your stakeholders. Please don't underestimate this. And so you might have already heard this, but you'll hear one more time, because correct, data is king. Like some people say, oh, algorithms is the king. It's so important to send that. Yeah, but I mean, data is really king. So important. So you gotta respect data. Like I've seen different types of ML practitioners. One camp sees data as like, varchar, big int, float, and the other side sees data as like things that needs to speak to him or her. I mean, the second type of people succeed much more in corporate setting, at least. So I really try to understand data and treat it with respect. It is super important in terms of data collection, governance, using the data, understanding data. It is super important. So in general, if I summarize like a data scientist, machine learning, in my opinion, of course, it's all subjective, our job is to capture most amount of information with the lowest degrees of freedom. And this is, I know, controversial, because, like, for example, some people say in the era of big data, there is no overfitting, right? So I do disagree. In fact, like, I ask this question in interviews all the time, and then just to create some debate. And the reason is that, yeah, I mean, you can always throw more data and then deal with the high variance problems. You can always throw more data and then deal with you don't need to worry about degrees of freedom, but you're going to maintain those models, and then those models needs to work, be sustainable. So in real life, no, in real life, simplicity wins. Think about Occam's razor, right? Always the simplest solution wins. So, and then biggest simplicity, and one big source of simplicity is the amount of data you use. So your independent variables, you need to understand them, and you need to use as least as possible. So one outcome of this is if you use so many, and it creates technical debt. So this is something that I'm going to spend the rest of the talk about. So what is it? It's kind of stating the obvious, I know, but it is like taking some shortcuts so that it creates some long-term costs, right? So some of it is necessary evil. You need to be pragmatic, you need to make some trade-off decisions, which might lead to some long-term technical debt. Yes, but eventually it needs to be serviced, right? It's like taxes, like you will pay it. And then how are you going to pay it? It could be like, code refactoring, doing more unit testing, deleting some old codes, integrating your APIs a bit better, continuous updating your documentation. It will be paid, and you will pay it. This is important too. So don't assume that, I'll build it and then I'll go and work on something else. So the model, I mean, I've been in corporate like for 20 years. So back in days, for example, you were a scientist, so you were building a prototype, someone else was deploying for you, and then they were on call. But nowadays, it's not happening anymore all that much. So generally now the responsibility is kind of combined. So if you build it, you will be on call if something goes wrong. So unless you change companies, you will be on call. So, and then people are incentivized to build like more reliable, less technical debt type of products too. So it is really good to understand how it's created and then avoid to create them. I think it's a very important skill set for ML practitioner too. So one big source of complexity or future technical debt is this thing called entanglement. You probably heard, right? The change anything changes everything. this is correct. Are your independent variables, for example, are not independent? You could say, yeah, they're independent. I check my BIF, there's no collinearity and that, but no, we're not talking about that. So a change in one of them, right? For example, the distribution of one of the independent variables changed, or the range, something changed, let's say, it impacts everything else. You will need to refit the model, maybe you got to add back a previous feature that you had moved out, or you're going to move out some other features. So things are really coupled, and not just your independent variables either. It could be your hyperparameter features, some thresholds that you use, or data selection criteria. So everything is really entangled, coupled quite a bit. So again, think simple, like no need to bring more than you should bring. Simplicity really wins. Even it's and you could say, well, I mean, but if I do that, I'm losing this percent accuracy gain. So first of all, no one cares about your accuracy gain. Everyone cares about business impact. And second of all, it's okay because speed to market, like delivering landing that impact sooner is super important too. It's also a big factor too. And then that's why the focus should be build my most viable product, launch it, experiment it nicely, show the impact, calculate the ROI. And then for the next iteration, see there will be a positive ROI compared to everything else you could do. If the answer is yes, okay, iterate the next version. This undeclared customers is another interesting problems too. So just imagine an ecosystem that let's say, 10,000 MLE. In some companies, there are thousands of machine learning engineers, and then they're all building models. And so guess what? They're all producing outputs, right? So for example, my model's output is stored in a table, your model's output is logged in a file, this and that. So, and then people are using those. And very often you don't know, right? So if you're the downstream and then you're using an upstream process, you know what you're using. It is easier. But if you're the upstream, generally you don't know your downstream unless you really think about that and put some controls, protocols, ways of working with potential customers. And it is important because these undeclared customers could really provide. So this is called as visibility. Actually, should be called a non-visibility debt, because lack of visibility is causing this coupling. It is definitely an issue. So in order to solve this is via communication, via other governance processes, some framework that you get to know your customers and then establish protocols, SLAs with them. So everyone knows what to use. Another also, the important thing to know here is you don't output more than you should. It is super important too. Like, for example, imagine you're running a model and then you're outputting all of your independent variables plus a few output variables too. Why? Because it was convenient. But then people are consuming from that layer, right? So instead of, you could put another layer on top of that, just put one or two fields and then publish them and then govern them much, much better. So the more you share, the more potential trouble you could get yourself to. And so this is like I mentioned briefly, the other side is correct too. Like they say, you're consuming someone else's, right? Of course, we are dealing with dynamic systems here. Not only people update these models all the time, but also the data that those models are using. Sometimes it's very dynamic too. So there could be changes in your upper funnel. But then these changes, if you don't know them, you might know that there is a change, but if you don't know the impact of that, then you might be caught off guard. And like I have experienced interesting things around this. For example, you consume someone else's output generally, it's not a good practice to use someone else's model's, for example, score, let's say, as an input to your model, in my opinion. Like, this is a bit controversial, I know, because like it's a big significance of the data that is in the enterprise tables are actually model outputs. So it is, I know it's generally impossible not to use any of them, but as much as possible, I wouldn't try not to use them if possible. If there are some proxy metrics that have less dependency on a different machine learning team, more like the raw kind of data, I would prefer try to use that. But let's say you're using, and then that team made an improvement to their model. Suddenly it's much more accurate. It might actually hurt your model. Because then if you don't know that the model, that data is now changed, if you knew, you will refit your model, and then maybe there were two other variables there, independent variables there before that you had removed because they had less collinearity, you will put it back, maybe, right? So that's why it is really important to know what you're using, and then generally bringing them into a layer, applying some governance, used to call them, some rules running on your input, so they check any kind of anomalies, any kind of distribution changes. Is really important to, of course, we have typical communication channels also you should build with your stakeholder, with your upstream stakeholders too, that you should know that they plan to work on this model, this and that. But let's say if they didn't, still some kind of a check on your inputs is super important. Like you probably heard, right? I mean, it's completely corridor, garbage in, garbage out. It is so important. So you gotta guard your input data like you're guarding your house. So important. And this is another silent type of underutilization, another silent type of technical debt that could accumulate. Some features, for example, so imagine that you had built first version of your models, you did your session there in the model now, and then there is several iterations later on too, and then some features they weren't so impactful anymore, so they didn't make cut line, but you kept them there, right? You thought, oh, you know, maybe in the next version I might use them, which is a good practice, but then you really layer them up, like in the, so put them in a one layer in terms of the database structure, and then whatever is closer to your training and the scoring tables, that needs to be as lean as possible, like as narrow as possible, because those legacy features, the features that bundle together, that just, for example, pull them together, but you only use two of them, they eventually add up and create complexity. And think about this, I mean, these models are going to be there to stay. Like some of the models they have been there for like 20 years. So they grow, even when you're, let's say, not working in the company anymore. So it is super important to try to keep lean, otherwise they compile very fast. Like they will compound very, very fast. And then like even like if we were to add every independent variable feature just because they are increasing your let's say accuracy or whatever you're trying to optimize for, we would end up adding so much. But generally, like we have very strong thresholds on that. Like in fact, how much incrementality you need for a independent variable to be pulled, added to your pipeline, all that cost is super important. Generally, the project team, develops a POV, point of view on that already. And they don't even work to bring that feature to their pipeline if they feel like that won't be high ROI. Yeah, and then, I mean, it's kind of stating the obvious, but one good way to find this one out, like what feature set is not being used anymore, is just doing like leave one out feature or just refitting the model again regularly, making it like a regular part of the model training, model maintenance framework. So, we are dealing with dynamic systems after all, because like, especially if your model is being used by the end consumer, let's say it's a ranking model, it's a recommendation model. So it's a dynamic system. Dynamic systems consist of feedback loops. So you need to be super careful about this. This is like, more people are talking about this, but this was definitely like it didn't get enough attention previously. For example, imagine like I worked on e-commerce. We had done quite a bit personalization. So imagine, let's say you're working for a company and then you're personalizing the homepage, right, of, let's say, deals.coach.com, for example, right? And then you personalize the content there. So what happens is people interact with that, right? And then based on their interaction, you have new data. And then that data will need to go back to your model, because you will need to keep your model trained. So the problem here is then you'll end up creating a circular reference, right? So this is very dangerous. This direct feedback loop is very dangerous, because the models, especially in the high engaged pages, high engaged use cases, I should say, they converge really fast. And this convergence is something that you should try to avoid. So randomness is a good thing for this. So this means like you need to find ways to introduce randomness to the process for at least two reasons. So one, it's just like you only know what you know, right? There should always be some exploration, so you can exploit those new unknowns, I will say. And two, if your training data is not doesn't have that randomness, then again, it is data leakage. Data leakage is of course a famous term, but generally people think about it like during model training. Do I have data leakage or not? Which is, as you guys know, right? So it is like your training data shouldn't see what it shouldn't see, right? So, for example, there shouldn't be any variables from your testing period or anything that at the time of scoring you won't know. It shouldn't make your training data. It sounds obvious, but actually generally there's some features find their way to training data and then create data leakage. So this is generally well thought through, but in the online setting, then you have a model that you will need to update regularly. That data leakage is less thought through. So either, for example, like I was saying, either instead of maybe a supervised learning model, maybe should be explore and exploit. Like, for example, for the use case I mentioned, for the personalizing the deals.coach.com homepage, for example, it is maybe MAB, like multi-bandit works much better. So there is that. But let's say you still need a supervised learning model that you will need to refit. Then maybe you will have a holdout population, so you can do your A/B testing. Maybe you should use that, the control for your training. Like, so you need to be aware of this data leakage, the direct feedback loop. But this is still the easier case than the hidden feedback loops too. So what hidden feedback loops are is that homepage I mentioned. In real life, there will be I don't know, like 5 different project team might be deploying dozens of models a year on the same, impacting the behavior on the same homepage, right? So so this means, yeah, let's say we fixed the problem that we broke our own convergence, our own models convergence, but what about someone else's, right? So they might be influencing and coupling each other too. So this is harder particularly harder because like if you're so focused on your own domain, generally as an ML team is giving a few top line metrics, and then they just heads down try to grow those metrics, meet their targets for the half, things like that. So that's why though generally like the leadership in their team, they help to connect those dots. Like this is this organization's metrics and goals, this is this organization's metrics and goals, and then they are all working towards optimizing them. They are impacting the same end customers. So that domain knowledge is important. And then with that, they try to decouple them as much as possible. I had mentioned the importance of experimentation platform. One way that we try to tackle them is via the experimentation platform, because in these platforms, in a test, you define universes for the customer or the end user, whoever you're testing. If you know that couplement, then you just put them in the same universe, for example, then things become orthogonal. So, but creating that domain knowledge is super important. And feedback loops are real. Whenever your model interacts with the real world, you should assume there's some feedback loop and then try to see if you can find it. So this is like, again, we build the pipeline, we will need to maintain that. And then we very often we use generic libraries and packages because they are awesome, they are there, someone has built this awesome library and package for us. But then what happens is, if in a big pipeline, either data pipeline or ML pipeline, then you got to glue them together. Like there's this generic package here, that generic package there, and then you glue them together. So this is actually slows down in the long run. It increases the complexity. The code feels like a bit like stitched together. So, and eventually it becomes really expensive to maintain that too. Containerization, building APIs, and then documenting them well, more like the service orient, like ML as a service kind of, but multiple services in one model. That is the way to go. It really saves lots of headache. So, as an ML practitioner in the corporate setting, you will be building pipelines non-stop, not just data pipelines, model pipelines too. And things evolved a lot. There are awesome pipelining tools for both data and model now. Some are in-house, some are third-party, some are open source, which is great. But think about it, for the model that has been there, for several years, different people worked on it different times, and multiple people are working at the same time. Let's say two data engineer, one MLE, this and that. Things really grow because people add, remove. It can really become like a jungle. You see joins, and then they filtered out later on, like bunch of. So refactoring it every once in a while is really, it's hard, but it's really necessary evil. Otherwise, what happens is, then if you don't do that, then at the end, lower funnel, your integration tests are going to be much more costly. So two things really help with that in the very beginning, thinking really holistically, and then designing before you even write the first line of code, how will my data flow, and then designing it, making part of your specs is really important. And also refactoring before you give too much of a break is really important too. Similar to this, you're using generic packages. Another common phenomena is there are multiple now good languages you can use for machine learning. So it's sometimes tempting to really build this part of the model, let's say on the H2O, and then this output this, and then this part, I do keras, this and that. It is generally not a good practice. So although most of the common pipeline mechanism makes it easier, still it just makes it harder in the long run. If you need to do it again, converting them to APIs and the content from the APIs is the way to go. but still, as much as possible, one single pipeline makes things much easier. So nowadays, the modern pipelines, most of the almost modeling is done by just configuration, right? So like hyperparameter tuning or all the other configurations are, most of the settings are done there. So then treating them properly, I mean, it's super important. Like how you configure, do sometimes like grid search and everything is a topic itself. But like, how do you let those configurations not to pile up and then the compound? So then when it's time to train the model, like you're scratching your hair, like you don't want that either. So like treating configuration with respect, there are now tools too that makes things much easier. But I think here the biggest motto line of thought is like, you should be thinking about configuration as part of the ML development and not as an afterthought. So similar to code, right? Whenever you have a control, like the code control system, let's say in Git and et al., configuration should be able to governed, documented accordingly too. You should be seeing diffs between different models, different versions of the models. It shouldn't be easy to make manual errors. It could be a bit like foolproof from that point of view. There should be some metadata about that, so you could easily see, you know, and then it should be checked into repository. And I said there are several tools. I know Facebook, for example, also open source Hydra that you guys can use. So I mentioned briefly in the dynamicity of the systems that we are dealing, right? So another maybe version of this is, so that one was more about like the model and the real world interacting. This one is like the external world is changing, right? So for example, let's say it's about recommending movies to people. The people's preferences might be changing, demographics might be changing, things like that. So this means not only, let's say, and then you could say, well, what is the problem? So I have my metrics, I can build some monitoring systems, and the accuracy is degrading. I could just say, okay, you know, let's time to repeat the model. Yes, you should definitely do it. Those monitoring systems is super important. But not only the model fitting and the features are in scope, even some like less thought things will be in scope. To, for example, thresholds, right? For example, you pick a fixed threshold. You say if the score is bigger than this, I'll do this. Less than this, I'll do that. Even those can change, and detecting those changes in the external world, and then when is a good time to refit my model, address my model. It is sometimes not easy, especially that feedback loop that I mentioned exists, because then it kind of slowly heats, right? So it's hard to notice. This is definitely something to be aware of, that we are dealing with a dynamic world. For that, even if you build a very high accurate model that you're so proud of, assume that you will need to refit that model, like not so time later. I think these are my closing marks. Some of them already probably I found a way to underline, but it doesn't hurt to repeat. So some advices for a future applied ML practitioner, right? So it is so super important to develop business acumen, gain domain knowledge. If you're in a corporate setup, that domain knowledge is so important. Not only helps you to build relationships, and then helps you to grow and land bigger impact, but also understanding the domain is really important. Like I was saying, unless then, not only quite likely you end up building wrong models, but even you might build the model wrong because you wouldn't understand the domain, your feature engineering wouldn't be so powerful. You might be missing some because those unknowns are problems. Like if you don't know what are you missing, it's going to be a problem. Super important to develop domain knowledge. Treat data with respect. I think I probably beat the dead horse here, but it is so important. Like otherwise, it won't speak to you, or it will mislead you. Data is so important. Like with domain knowledge, taking the time to understand it, that understanding, and then closing the loop with your stakeholders while you're building the model, share the understanding with them is super important too. Another, in my opinion, pitfall people fall a lot, especially more like the people who are just entering the area, is just the hypes. When, for example, deep learning just became popular, like, you know, I mean, I shouldn't say, but like in the interviews, like everyone was throwing words around, like, yeah, I built this CNN, I built this, I built that, but they didn't know what model fitting is. Like they didn't know the maths behind fitting. They don't know how logistic regression is, or the odds ratio is, like even the simplest things. So not only it is so important to develop the like the foundation strong, but also like in many cases that you don't need really the most cutting edge algorithm or whatever is so popular nowadays, especially in corporate setting. Everything is about the impact. Like having that set mind, if your mind is working in the corporate, having that mind of like, you know, thinking, establishing earlier is super important. I mean, this is, you guys probably all already know this, but my point of view is like machine learning is all about bias variance trade-off. Like, so understanding this concept, seeing all the parameter tuning, be at this point of view, understanding all the algorithms and their parameters from this point of view, super important. Not only it helps you with the modeling itself, in my opinion, it helps you with the data itself too, because it's all about data complexity versus the model complexity after all. For the next level, like, you know, if you, in my opinion, under the hood is ML is an optimization problem. So having a good optimization or background really helps. It's what I observed. Don't ignore ML ops. Like what I'm trying to say is there are algos. Okay, I learned that it's most recent algo and I'm good. Fortunately or unfortunately, it's mostly becoming ML ops nowadays. Scale really matters. So yeah, I mean, in the corporate setting, it is so important. So don't ignore. And my last comment, I probably mentioned already 7 times, but like think big, but implement small. Like big meaning that like end to end and holistic, but implement small. Like be modest, be incremental, step by step, and then make sure that you can always measure your impact, your impact and your model's impact. Cool. It's pretty much it. I don't think I managed my time so good, but sorry for that, guys.
Okay. Afşin, thank you very much. So it is a very nice talk, also from a perspective of academic studies as well. So there are some lessons that we need to learn, especially for preferring the simplest models if they solve our problems. So there are lots of good things that we need to hear from you as well. So I would like to ask the audience first. So any questions? Any questions to Afşin?
I can ask one quickly. Hello, very nice talk. Thanks for that. One thing like I found interesting is like it's usually in academia we miss the like maintenance side of things, right? That's why you said, you know, don't ignore MLOps. But one thing I'm seeing is, you know, this like large scale MLOps is relatively new in Turkish industry. And one of the problems is IT integration, right? For example, for a bank, the IT is built on large SQL databases and just fast responses. Like you can't really inject. It's real difficult to inject like Python code there to just do something that's. I don't know if you have any experience because you've been in this game for a while. Have you had similar experiences in the US? And secondly, perhaps related, you said developers are also responsible for maintaining the code. I've always thought that to be like, you have data scientists and data engineers or like maintainers. Is that really the best use of the developers? I mean, I get your point saying that, hey, if they need to maintain it, they'll write better code. But on the other hand, if something bad happens, is it really worth their time?
Yeah, both good questions. So quick answers. So I definitely sympathize the first. I mean, it has been a journey. I mean, here too, still, even in the US, not all companies have the same maturity level. I started my career in a bank, Merrill Lynch. So built my first logistic regression model in SQL. So I think it is normal. It takes some time. There isn't much that you could do, in my opinion, but if you happen to work in that kind of setting and as a decision maker that could help company to, let's say, move on a distributed computing, again, then I think you should apply like Occam's razor, like, then, okay, given the circumstances, then maybe a linear model, like you just, whatever is easier there, like you shouldn't go too fancy. Instead of building something like too disjoint, and then like working with flat files, you build your own MySQL version so you could build your own ML apps. I would integrate with in the enterprise setting, even it is a bit a few years behind. On the second question, I mean, things are changing, whatever. I mean, it's not up to us really, because it was like that. Like when I first started, we were just building prototypes mostly. But it was painful too, like, because the issue is, imagine, like, say it's a Java company, a Java shop, but your data science only know R or Python, right? Then what? So that was the case before. This is like our SAS days, all days. So then they used to convert things to PNML, and then like they used to wrap it with a code and then deploy it, and then doing that. Imagine all these complexes I mentioned that requires like the training, all of those. Imagine them in that setting, that you give someone this, they wrap it up, and then they build. So many companies, like starting maybe 10 years ago, really shifted from this to full stack ML scientists. So some components are really ops, like for example, they have data engineering. Right, so they maintain some of the components, but the core components that touch like close to the metal, like close to the model, you will end up maintaining it in most of the companies nowadays.
Thank you.
Great questions, of course.
There's also one good question in the chat window. So from Atalay.
Yeah.
So he mentioned.
This is a fantastic question. I wish I had more time to talk about this one. So I actually gave an example there, but maybe I didn't double click so much. For this happened to me so many times. So I used to work for eBay, and the last 2 years I head up the marketing science team. So very often, your business comes to you. I own this segment, and then my customers are churning. I want to know which customers are going to churn. Right? If you're a naive data scientist, you will just, sure, you can build a churn model for you. You just collect historical data, you build like a propensity model. That will be wrong. Because imagine, let's say there are like 5 million customers. I rank them by the propensity of churn. And I gave it to business. So what are they going to do with it? Like, let's say if my propensity churn is 99% versus yours is 75, what are they going to do? Like, maybe I am a lost case anyways. and even they send me a campaign or a marketing campaign or a coupon, I will churn anyways because 99.9%. So the solution here, there should be incremental net lift, uplift modeling. Like if I give this treatment to the customer, how much I will change that behavior, in this case, the churn behavior. That's completely different modeling technique. So that's why unless you ask 5 times whys, okay, sure, I can build for you. Why? Right? Okay, because I need this. That's great. Why do you need this? Unless you ask those 5 whys or like layered so whats, you won't get to the real problem. And unless you don't get to the real problem, you'll probably build the wrong model. That's why I keep saying, like, think about the end from the very beginning. Always ask, like, how are you going to use it? And then that is going to reveal a bunch of information.
Okay, any questions, more questions? So I have one last question. So from a perspective of a corporate setting, what are your ideas about academic projects?
In which context? Like you're asking
so
this.
You know that there are lots of academic projects that aim to build more powerful, more accurate models. So you mentioned the importance of simplicity as well, but like in academia, we are still working on like designing complex models.
I think some problems, like for example, like some problems, there's perfectly set up for academic section because data is more confined, more static. For example, anything on image I think is like that, right? So they don't change, like the inputs don't change. Very complex but confined problems. There isn't much interaction with the user so much, like the end user so much. So for that kind of stuff, that accuracy itself is so important because like you're able to detect if it is a bird or a cat, for example. Makes perfect sense. But in the settings that like the model itself is a part of a product, and there is this constant interaction between the end user and the model. Any academic research would be hard, like because the model will need to exist, live in that ecosystem that interacts with the product and with the end user. You cannot build it in isolation and then say, okay, deploy this. Those feedback loops, the experimentation is so important. I mean, this experimentation culture, this was a big shock for me too, even within the US. When I work for like change companies, I realized, for example, like there are some companies, the experimentation culture is so strong. Like for example, when I first come to Meta, I was shocked that like there are like at least 10,000 experiments running at a given day. Like the scale of experimentation is so important, so huge, and how important the experimentation to the product development and model development cycle is so important too. That kind of problem, experimentation is so important. I think academic setting wouldn't be that best setup in my opinion to establish, but more confined, accuracy important kind of projects. Yeah, I think perfect setup.
Thank you very much. More questions?
Of course.
To our speaker. Okay, once again, thank you very much, Afşin, for
of course, it was a pleasure. Thanks for inviting me.
Hopefully, see you later.
I hope so too.
As well. Okay, thank you very much.
Inshallah.